So good morning, guys, and today this talk right now is going to be about fixing the browser fingerprinting vulnerabilities. Today we have Xiaoyin who has already discovered 2 bugs in the fingerprinting of web browsers, and he will be discussing about the vulnerabilities that he has found and what are the fixes and what were the bypass that he found for those fixes as well. So over to you, Xiaoyin.
Okay, thank you so much. Okay, so hello everyone, good morning. My name is Xiaoyin Liu, and I come from China. Today I'm very happy to come here to B-Sides, so that I can share with you some of my findings in information security. Okay, so first of all, this is a brief introduction of myself. I'm an independent bug bounty hunter. I graduated from the University of North Carolina at Chapel Hill. It's a university in the United States. And I study mathematics and computer science at the college. I'm recognized by Microsoft, Google, Brave Browser, Tor project, and many more for the vulnerabilities that are found in their products. My areas of interest include Windows applications, web browsers, and I'm also like to do the source code auditing in C and C++. Okay, so here's a brief outline of my talk today. First of all, I will tell you what are the fingerprinting issues in web browser, and then we will focus on one specific fingerprinting issue, which is called SNIFFLY attack. And then I will talk about 2 bypasses that are found in their patch, and then the takeaways. And finally, I will share with you another vulnerability in Microsoft Edge, which is CVE 2017-0135. Okay, so first of all, let's talk about what are the browser fingerprinting issues. So the fingerprinting issues refers to the flaws in web browsers that allow websites to track users or allow them to know some private information about users, like browsing history. This is why I think fingerprinting is a private issues. But very unfortunately, many of the browser vendors, they don't think fingerprinting issues are security issues, so they are not likely to fix them in a quick manner, unless you use Tor browser, which is designed to protect your privacy. So if you like privacy, I encourage you to use Tor browser a lot. And some of the examples of fingerprinting issues in the past include HSTS super cookie issue and CSS visited issue. But today, I will just talk about the SNIFFLY attack. The SNIFFLY attack was discovered by Yan Zhu in 2015. This attack abuses HSTS and Xiaoyin redirect and content security policy to check users' browsing history. This vulnerability is assigned CVE 2016-16-17. Okay, so before we talk about SNIFFLY, let's quickly review what is the HSTS and content security policy. So HSTS is HTTP strict transport security. It is a browser security feature that allows websites to enforce HTTPS for all connections to their server. So there will be no plain text HTTP connection to the domains that have enabled HSTS. And this policy is delivered in HTTP header, strict transport security. You can see on the second line, this is a HSTS header that the server sends to the browser. Strict transport security max age. Okay. And next is the content security policy. And the content security policy is another security feature in web browser. It was designed to mitigate cross-site scripting attacks. And the second line is also a content security policy header. It's also HTTP header sent by the server to the client. Content security policy. So this means whenever, even if there's a process scripting vulnerability on the web page, it's harder for the attackers to exploit it because you can only connect to the same domain, which is the self, and then also the www.google.com. So you cannot load scripts from other domains, including the attacker's domain. And more recently, CSP is also used to deliver some other security features like upgrade insecure requests, but that's not quite related to the SNIFFLY attack. Okay, so next let's talk about how SNIFFLY works. So SNIFFLY is actually quite simple because it's just an image tag. It starts from an image tag. So like this. So you can see the URL here, example.com. It is, you cannot check an arbitrary URL and see if the user has visited that. But if you know that example.com is either a HSTS domain or it redirects from HTTP to HTTPS, then you can use that in an image tag. And if the user has never visited this URL, this is what happens. So the first, when the browser tries to fetch this URL, the first request is HTTP example.com. And this request is sent to the server. And then the server replies a 301 redirect to the browser, which is location HTTPS. And then the browser will send the HTTPS request to the server, and then you get back the web page. But if you have visited this URL, this is what will happen. What happens is that the redirect is also cached in the browser. So this first request is an in-browser internal redirect, and then the second request goes to the server, and then you get back the actual HTML page. It's usually cached because HSTS is, as I just said, is saved in the browser, and 301 redirect is usually cacheable. So if we want to know if the user has visited this URL, what you can do is that if you can time how long it takes for the redirect to happen, you can know if it's an in-browser redirect or it's a network redirect. Okay? But in order to do that, it's necessary to block the HTTPS request to the server, because usually when you have a redirect, the browser will automatically follow the redirect, and then you can only time the entire time for both requests. But here we only need to time the first request, which is the redirect part. So we have to find a way to block this second request, which is the key for the SNIFFLY attack. So how does it work? We use the content security policy to block the HTTPS. So you can see here's a header, image src http://example.com. This means you can only load image from HTTP example.com, not HTTPS example.com. So essentially the HTTPS request will be blocked. And in our testing, it shows that if the error event, which is triggered here because of the CSP policy, there will be an error event fired here. So if the error event is fired within 10 milliseconds, then we know it's an internal redirect. Otherwise, it's a network redirect, which means that URL has never been visited. Okay, and then here's the code snippet of the patch. You can see that they changed the scheme matches. So if the scheme of the CSP is HTTP, then it now matches both HTTP and HTTPS. Similarly, for the WebSocket protocol, it's also WS now matches both WS and WSS. So now the same CSP header now matches both HTTP example.com and HTTPS example.com. this means we can no longer exploit the SNIFFLY attack, because now you cannot use this header to block the HTTPS request. Okay, so next, how I bypass the fix. I realized that the code only considers the protocol part, not the port part. So let's consider this CSP rule. Content security policy image SRC. So basically I just add the port number 80 to this URL. And now the question is, does this one match HTTPS :/example.com? It turns out this CSP maps HTTP with port 80 and HTTPS with port 80, but it does not match HTTPS with port 443, which is the port for HTTPS. This means we can use this content security policy to block HTTPS requests once again. Once we can do that, we can exploit the SNIFFLY again. And this is just a very small change, and then it just works. And I found that both Google Chrome and Firefox are vulnerable to this bug. And I reported to both of the tickets are here, and they also assigned 2 CVEs for each browser. And then Google gave me $1,000 for the bounty. And here's the patch for my attack. You can see here, if the port is 80, it now matches 443. Okay. And not only the change in the code, they also change the CSP specification to match the fix. You can see that they change that to remind people of the attack. Okay, so they now fix the first bypass, and then I was wondering if there is a second bypass, and it turns out yes. So far we use the content security policy to block the HTTPS request, but are there any other ways to achieve the same effect? Actually, yes. So I just found that we can use Fetch API to do that. So what is Fetch API? The Fetch API is a quite new JavaScript API, allow you to retrieve a URL. And the very good thing about the Fetch API is that it allows you to customize the request. And one of the features is the redirect mode. The redirect mode has 3 values: follow, arrow, or menu. The follow is the normal one, which you get the final response after following all the redirects. But here, what we need is the manual redirect. The manual redirect allows you to handle the redirect manually, which basically means you can get a callback whenever there's a redirect happens, which is exactly what we need for the SNIFFLY attack. Because this time we don't even need to block the HTTPS. We can just get called when the redirect is received. And this is a very simple POC. I set the redirect mode to manual, and then I can just get the response. If the response status is 301, it means it's a redirect response. And then I can just stop the timer here. If the interval is less than 10 milliseconds, it's waited, otherwise it's not. And then I reported this in 2016, and they didn't fix it for more than 2 hours, for 2 years. And then finally I recently found it's fixed silently, because they didn't update the ticket. When I try that, it says no CORS cannot be used together with manual redirect, which means I can no longer handle the redirect if it's a cross-origin request, which is basically what we try to exploit in the SNIFFLY attack. Okay. And so this is the takeaways from my experience in the 2 bypasses. Basically, I just want to encourage you to read the reports and the write-ups, and if you understand them and you implement your own POC, maybe you can just find some easy bugs from that. Okay, and then I will talk about another vulnerability to show that it's really useful to read other people's reports. And this is CVE 2017-0135. This one, I got the inspiration from this paper of using Internet Explorer 8 cross-site screening filters. It was written by these two people. And first of all, the paper tells me how the cross-site screening filter works. So basically, the cross-site screening filter is used to mitigate reflected cross-site scripting attack. It checks if any URL parameter seems to be a cross-site scripting payload. So for example, this URL, the ID parameter is a script attack. So Internet Explorer thinks this can be potentially a cross-site scripting payload. And then it checks if in the HTML there's a same string. If there's a same string, it changes the script tag to sc#ipt. Basically, this script is just disabled. But what if it's not a reflected cross-site scripting, but it's an actual JS code in the HTML source? So for example, if this page, example.com index.php, what if this page tries to load jQuery.js? And then I give you this URL, I append the script tag to the URL. Now what happens is that the browser thinks this is a cross-site scripting attack because this substring is also contained in the HTML file. So the filter changes the script to sc#ipt once again. So the jQuery just won't load. They know this attack pretty early, but they think it's pretty harmless because they just think it's just as if jQuery.js doesn't exist, because it can't load for some other reasons, like the network issues or the server issue, if it returns 404 like that. But I found, is that really harmless? It turns out no, because I can abuse the cross-site screening filter to disable CSV. The CSV, as I just said, CSV can be delivered in HTTP header, but it can also be delivered in a meta tag. This is a meta tag to set the content security policy. Now, what I'm doing here is that I append this whole tag to a URL. As I just said for the jQuery example, they also think this meta tag is a cross-site scripting attack because it's reflected in the HTML. And what they are doing is that they change the meta tag to me-a, which means this tag is disabled. So I created another very simple POC. I just add a meta tag in the header, and then here's a script alert. If the content security policy is in false, there should be no alert because of that. This is an inline script, and it only allows self-script. But if the content security policy is disabled by the filter, this alert will show up. And it turns out, if I visit this URL now, this is what happens. This is a pop-up shown by the Microsoft Edge, which means we get a new vulnerability. This is exciting, pretty exciting. And I reported it to Microsoft on December 2016, and it's fixed in March 2017, and the bounty is 1,500. Actually, they recently removed the cross-site screening filter entirely from Microsoft Edge in 2018 because of the attacks like that. There are many attacks like to abuse the cross-site screening filter, and it also incurs performance costs, so they just decided to remove that. Okay, and these are references from my talk. And okay, thank you for listening. Other questions?
Okay, thank you. Do we have any questions from the audience? True. Don't be shy. I'll get you the microphone.
So just one question, how much time does it take you to find out these, how much work do you put into it?
Actually, less than 1 hour after I read the report. The first thing I test is the port, add the port to the URL, and then it just works. Actually, it's very surprising to me. So less than 1 hour, basically. And then, I spent, I think, another less than 1 hour to find the second bypass. And, similarly for the cross-site screen field, it's also about 1 or 2 hours, I think. Yeah. Basically. Any other question?
Okay. Yeah, it's like an interesting talk. I mean, if you only research for 1 or 2 hours, but you probably, I'm not aware, what are you doing on your daily basis then?
On my daily basis?
Or, yeah, do you just work like 2 hours to find bugs and then...
Just relax after that. Well, I read books. Read books about, like the Windows internals. And then read reports. And then I also program a lot. And contribute to open source projects.
Or just count the dollars that you receive as monthly rewards.
Huh? Sir?
Just count the dollars that you receive.
Yeah. Okay.
How many bugs do you find per month? Or
per month?
I think it was loaded.
Oh,
sorry.
Okay.
How many bugs do you find per month?
Not many, like 2 or 3. There are a lot of private programs that invite me to fund like that.
So you spend your time reading reports a lot.
Yeah, read reports and as well as books.
Oh, okay.
Yeah, not just reports.
So these bugs were from 2016 and 2017.
Yeah.
What are you looking into today?
I look into other areas, like the, I also studied the web browser recently, and then I also found some, there are 2 vulnerabilities that I found, and they are not fixed yet in Google Chrome. So, something like that recently. These are all the bugs, but I also found something new, in 2018 and 19, but it's just not in today's talk. Did I answer your question?
Next year again.
Huh?
So you will visit us next year again with your...
Yeah. You have the chance.
And do you think, how does bug hunting in China generally work? Do you work alone, or do you also have peers that you work with?
I basically work alone. I just work at home. Basically like that. There was a community in China, in about 2013 to 2015, there was a community called Wuyun, but it was shut down by the government. So after that, there are no communities that I know or I participate.
Okay. If we don't have any more questions on the recording, then thank you very much for your interesting talk.
Okay, thank you very much.